All right, guys, we're back with section 6 of chapter 1, which deals with something called relations. So previously, we solved equations with one or two variables, and now we're going to talk about how to represent relations and interpret graphs of relations. So we have a bit of vocabulary here, but most of it you should probably be familiar with. We're just going to kind of review and refresh it for now. So we have the coordinate system, the coordinate plane, the x and y axes, the origin, ordered pair, x and y coordinates, relation, mapping, domain, range, independent variable, and dependent variable. So the first thing we want to talk about in this first video on this section is how to represent a relation. This relationship between the depth and pressure exerted can be represented by a line on the coordinate grid. And what this is talking about is the problem that deals with the depth in the ocean and the amount of pressure that is exerted on something or someone depending on how deep you are. And that's on page 40 in the book. So that is a relationship. How deep you go, the pressure increases. There's just a relationship involved there. Kind of like if you go to the store and you buy lettuce, the more heads of lettuce that you buy or more bags of lettuce, the larger your bill is going to be, right? There's a relationship between the amount of things you buy and the cost or the total amount of your bill, right? So a coordinate system is formed by the intersection of two number lines, the horizontal axis and the vertical axis. So the horizontal axis is called the x-axis, and the vertical axis is called the y-axis. You're probably very familiar with this, but sometimes I've noticed that students flip-flop them and they forget which one is x and which one is y. Here's how I remember it. You think first, alphabetical order, x comes before y. And way back when you first started learning number lines, didn't you learn number lines in a horizontal number line? Like way back, I don't know, kindergarten, first grade, when you first looked at numbers on a number line, right? So I just remember that x comes before y, and I learned the horizontal axis before I learned about the vertical axis. So that's the x and y axis. The coordinate plane is the square kind of that's formed by the intersection of the x and y axis. Now you have two dimensions, and you can go different places on that plane. So each point is named by an ordered pair. The first number, again, here we go, alphabetical, is how many units you moved in the x direction to get to that point. So we moved 2 units to the right. And the second number is how many units you moved in the y direction, vertically, 3 units up. So if I start at the origin, which is where you always start when you're trying to graph a point, you would move 2 units to the right and 3 units up. The origin, which is the middle of the coordinate plane where the x and y axis intersect, that coordinate is known as 0, 0, because you didn't move left or right or up or down. Okay, so a point is represented on the graph using ordered pairs, and that's a set of numbers or coordinates that's written x, y, just like 2, 3 right here is a coordinate. We talked a little bit about that. So the x value is called the x coordinate, and it represents the horizontal placement of the point. And then the y value is called the y coordinate, and that represents the vertical placement of the point. And just so you know, positive and negative numbers make a difference. If you have a positive number, that means you're moving forward or up, depending on whether it's an x or y coordinate. And if it's a negative number, you're going to move to the left or down, depending on if it's an x or y coordinate. So a set of ordered pairs is called a relation. A relation can be represented in several different ways. You can use a graph, you can use a table, or you can use what's called a mapping diagram, or just plain old mapping. A mapping illustrates how each element of the domain, or the x values, is paired with an element in the range, or the y values. So domain stands for the set of x values, the range stands for the set of y values, and a mapping shows how the x values are related to the y values. So the set of first numbers of the ordered pairs is the domain, and the set of second numbers is the range. This mapping represents the ordered pairs -2, 4, so see how -2 is mapped to 4, -1, 4, -1's mapped to 4, 0, 6, 1, 8, and 2, 8 as well. And you can see the mapping right there. So let's study the different representations of the same table below. So you have ordered pairs here, and you have a table here. So you can, or the same relation, excuse me, you have a table. Graphically, you can put these points on here like 1, 2. You start at the origin, move to the right 1, up 2. For -2, 4, you start at the origin again, move to the left 2, up 4. In 0, 3, you move to the left or right 0 units, so you stay there, and then a -3 means you move down 3. In a mapping diagram, 1 maps with 2, -2 maps with 4, and 0 maps with -3. So the x values of a relation are the members of the domain, like I said a couple seconds ago, and the y values of a relation are members of the range. So in the relation above, the domain is -2, 1, 0, because those are the x values. You can see right here in the table, the first value of the ordered pair or the domain elements. And the range is -3, 2, 4. The -3, 2, 4 come from the y values of the ordered pairs or the table or the range of the mapping. So here's an example. We want to express this set of ordered pairs as a table, a graph, and a mapping. A table is pretty easy. You just make a column for x, a column for y, and match up all the x values with the y values that they correspond with from the ordered pairs. So x values are 2, -2, 5, and -1. And if you want to put them in order, that's fine. You know, if you wanted to go -2, -1, 2, and then 5, just make sure that you put the correct corresponding y value. All right, if you put your x values in order from least to greatest, you don't necessarily put the y values from least to greatest. You have to still put the numbers that they map with. Okay. If I graph it, here's all 4 ordered pairs. Again, we start at the origin. I didn't quite get that right on there. You start at the origin. And say for 2, 5, you want to move to the right 2 units and up 5. That would be that point. -2, 3, you move to the left 2 units and up 3, and so forth and so on till you get all of the ordered pairs on there. Okay. And then a mapping, you list the x values in a domain, the y values in a range, and you just simply draw arrows from the elements in the domain that they map to with the elements in the range. And notice that 5 and -1 both map to -2. You don't have to put -2 on the range twice. You just put 2 arrows pointing to it from the 5 and the -1. All right, so let's determine the domain and range of the function, or the relation, excuse me, which we've already kind of done when we did the mapping diagram. So all we have to do is just list them out. And again, since it's a set of numbers, you're going to separate them with commas and put braces around them, not parentheses, because parentheses typically indicate ordered pairs. So you don't want to get that confused. You want to put all the domain elements in braces and the range elements in braces as well. Now, let me just say this. Notice in the table you had to put -2 2 times, as well as in the ordered pairs, because they were mapped with these numbers. But when you're listing the individual elements in the range or domain as a mapping diagram or in a set of elements of the domain and range, you don't have to keep repeating the numbers if they come up more than once. All right, so let's express these points as a table, graph, and mapping diagram and determine the domain and range. Go ahead and pause the video and hit play when you're ready. All right, we're back. Oop, accidentally hit that. So a table, you would do x, y, and 4, 3, -4, 0. Then 4 is mapped with -3, 3 is mapped with 2, -4 is mapped with 1, and 0 is mapped with -3. As a graph, 4, -3 would be there. 3, 2 would be there. -4, 1 would be right there. And 0, -3 would be right there. A mapping, I'm just going to put a D and a R. Put some bubbles. The domain is 4, 3, -4, 0. And the range is -3, 2, 1. 4 goes with -3. 3 goes with 2. -4 goes with 1. And 0 also goes with -3. So the domain would be the set 4, 3, negative 4, 0. And the range would be the set negative 3, comma 2, comma 1. So when you do the mapping, you pretty much already did the domain and range part. Now you just have to list it out. All right. Alrighty, in a relation, the value of the variable determines the output is called the independent variable. The variable with a value that is dependent on the value of the independent variable is called the dependent variable. The domain contains values of the independent variable, and the range contains values of the dependent variable. So let's identify the independent and dependent variables for each relation. The dance committee is selling tickets to the fall ball. The more tickets that they sell, the greater the amount of money they can spend for decorations. So the number of tickets sold would be the independent variable because it's unaffected by the money spent on decorations. The money spent on decorations is the dependent variable because it depends on the number of tickets sold. That's kind of how you can think about it in this problem. Okay, so generally the average price of going to movies has steadily increased over time. What are the two quantities involved here? Well, the price and time. Okay, time is the independent variable because it's unaffected by the cost of attending movies. The price of the movies is the dependent variable because it's affected by time. It depends on how much time has gone by. So let's identify the independent and dependent variables for each relation. Go ahead and pause the video and read it and hit play when you're ready. Okay, we're back. So 2A, the air pressure inside a tire increases with the temperature. Since temperature is unaffected by the air pressure, but air pressure is affected by the temperature, that means air pressure depends on the temperature. So air pressure is the dependent variable and temperature is the independent variable. 2B, the amount of rain decreases. As the amount of rain decreases, so does the water level of the river. So here, the amount of water in the river is affected by the amount of rain that falls. The amount of water in the river isn't going to determine the amount of rainfall, it's the other way around. So the amount of rain is the independent variable, and the water level of the river is the dependent variable because it depends on the amount of rain. All right, guys, that's it for this video. Stay tuned and jump down to the next video because there we're going to talk about the graph of a relation.